let me share my screen. Can you see the slides?
Yep.
Oh, okay. So, hello everyone. My name is Enrico Olivelli. I'm working at DataStax in the linear streaming team, and basically we help users and enterprises to use Pulsar and streaming technologies in general. And member of the Apache the PMC, the Project Management Committee of Pulsar, of Apache BookKeeper, ZooKeeper, and a couple of other Apache projects. So I really love open source and Java. So that's me. What are we going to do today? I'm going to talk about JMS, the Java Messaging Service API. It's pretty old, but there are many companies that are still using it. We will see what is Pulsar and why it makes sense to take a look at Pulsar now in 2021, 2022. And we will see really how Pulsar works at a very high level. And we will see how you can map the JMS concept to Pulsar. And we will see some little piece of code, how to use the JMS API with Pulsar, and I will show you a live demo. So let's start. The Java Messaging Service API. JMS is really like JDBC. JDBC is for the databases, standard API, so you can run your SQL queries and you can connect to SQL databases. And for JMS, it's the same thing. You can connect to messaging systems like Apache ActiveMQ and every kind of messaging system that supports this API. And basically with JMS, you can produce and consume messages. You can manage subscriptions. You can deal with transactions. And there is also a language, very simple language to filter the messages when you are consuming them. So only for APIs, not that big. The core concepts of JMS. JMS is really about having destinations that are containers of messages, sequences of messages. There are producers that put the messages into the queues or the topics, and consumers that read and process the messages. There are the concepts of connections, that is the physical connection to the broker, and sessions, that is another abstract concept that has disappeared in JMS 2.0 and leaving space for JMS context. So it's very simple for who knows messaging systems. It's very simple. You produce messages and someone processes messages. Deep down, destinations you have two kinds of destination. You have the queue. In the queue, multiple producers can put messages into the queue, but each message is received or eventually processed by only one consumer. And you can browse the contents of the queue and see the messages that have not been processed yet. And the topic allows multiple producers to put messages into the destination, but then you have multiple subscriptions and the consumers will receive messages from the topic according to the subscription type. You have two ways of consuming messages. There is a blocking API, the receive messages. And so this way it is the application that pulls for messages. And you have a message listener API. And in this case, it is the JMS driver that pushes messages to the application when they are available. And you have two ways of producing messages. There is a blocking API, send method, and there is an asynchronous send API, and you pass a callback that is executed when the message, the delivery is completed. This is new in 2.0. Many systems still support only 1.0 or 1.1. So that's it. But what is missing in the JMS API is the admin operations. So with JMS, really, you cannot manage the destinations, you cannot manage connection properties, so nothing about the TLS or security. There is only some method to perform username and password authentication, and no concept of resource limits, quotas, or quality of service. Everything is to be configured in some vendor-specific management tools. This is good because every messaging system is different from the others. And so it is better that in order to administer okay, we have questions. Probably we will leave a question for the end. Yes, it's better. Okay, so and the API starts when you use the JMS API, you start by having these administered objects that are provided by the container or by the environment. So someone has to provide you queues and topic references, so the destinations, and a connection factory that is actually the client that allows you to connect to the system. We will see this later in some code. If you're running a Java application inside a Java Enterprise container or Jakarta Enterprise, I'm still not used to Jakarta, sorry. The Java Enterprise application, you use Enterprise Java Beans, and with EJBs, you have stateful, stateless Enterprise Java Beans. You can implement servlets, web services. You can easily implement background tasks, and you have message-driven beans that are activated by the container when receiving a message from a connector, and usually the most common connector is the JMS connector. It is the Java Enterprise connector that container, that provides support for the management of the life cycle of every component, to connect all the components with CDI. It handles transactions, and also it provides standard API to interact with the rest of the system. This is Java Enterprise. In the Java Enterprise world, if you want to use JMS, usually you deploy a resource adapter. The resource adapter is basically a jar file with a rar extension, and you configure the resource adapter, and then you can create administered objects, so the connection factories, the queue reference, the topic reference, and usually you bind these to a JNDI registry. And their application uses JNDI to get those objects. But how the resource adapter is a standard API, but how to deploy a RAR file is specific to the container. We will see an example with Apache TomEE. Let's talk about Pulsar. What is Pulsar? Pulsar is a cloud-native distributed messaging platform. It is an open source project. It was born in Yahoo, like many other libraries in the big data ecosystem, and Yahoo donated it to the Apache Software Foundation a couple of years ago, so you can find it on GitHub. The key points for Pulsar are the scalable storage that is built with another Apache project, Apache BookKeeper. It was designed and born with multi-tenancy in mind, so if you are running Pulsar, you have separate, isolated spaces for your data, for your topics. It brings support for geo-replication out of the box, so you can connect multiple Pulsar clusters in different regions or availability zones or whatever you want. And you can easily produce and consume to remote clusters transparently. It supports to offloading all data to object storages like S3, Google Cloud Storage. So basically, you can move your old data to a cheaper storage that is not local to the cluster. It brings native Kubernetes support. There is the schema registry that supports Avro, JSON, and Google Protobuf schemas. There is the Pulsar IO framework that allows you to connect your topics, your Pulsar topics, with the other systems like Cassandra, Elasticsearch, or you can perform CDC, capture data change with Division. There is the Pulsar function framework that is a very lightweight messaging processing framework to process the messages while the data is still inside Pulsar. So you connect separate systems with Pulsar, but you can also transform the data when it is inside Pulsar. And the community, the Pulsar community, supports many client bindings, especially the Java, C++, and Python bindings. But we're also supporting natively Go, Node.js, C#. Some other facts about Pulsar. Pulsar was born to deliver millions of messages per second with very, very low latency. You can horizontally scale every component in the cluster. We will see this later. And also you can move your data. When you don't use it that often, you can move it to cheaper storage. You can also consolidate many existing JMS applications into one single Pulsar cluster, because usually JMS brokers are not very scalable, and you are used to create separate clusters of JMS brokers. But with Pulsar and with the horizontal scalability capabilities and the multi-tenancy features, you can connect everything and put everything into one single Pulsar cluster. You can also configure retention, so you can keep your data for a given amount of time or forever. So for instance, you can replay your data with a new version of the application while developing, or if you have a bug and you want to fix and rebuild everything. It supports J replication, like I said before. And also, if you think about Pulsar and you are already running JMS, you can switch to you can put your application, JMS application, to Pulsar, and you can start running many modern workloads like event sourcing, event streaming, log collection, many interesting things that are really typical of this second generation of streaming platform like Pulsar. Let's see how Pulsar works at very high level. So if you install a Pulsar cluster, you have the brokers that are the processes, the services that dispatch messages, and the brokers are stateless, so you can scale out and scale down the brokers very easily. And you have the bookies that are the storage nodes. These are implemented with Apache BookKeeper, and this is the same thing. You can scale out and scale down the bookies, and when you add new machines, the cluster automatically uses the new machines. And you have not to perform a rebalance operation, reassigning things to the new data nodes. Everything can work automatically. You have to provide a metadata service, and usually you are using Apache ZooKeeper. And if you're running, especially in Kubernetes, you want to expose the service to external clients, you set up the Pulsar proxy, that is a dedicated proxy service for the Pulsar protocol. And then outside the Pulsar cluster itself, you have your applications, so your producers, your consumers, and you can run Pulsar function workers, as said, so you can transform your data while it is inside Pulsar, and you can deploy Pulsar your connectors, sources and sinks, For instance, there is support out of the box for Cassandra, for Elasticsearch, for Oracle, both for writing, so things, and both for reading, so capture data change. And as I said before, you can connect S3, Google Cloud Storage, or also HDFS, or you can implement your plugin to offload your data, your cold data. Let's see the model, logical model for Pulsar. In Pulsar, you have topics and subscription. So there is no difference between queues and topics. You have topics, and topics can be persistent. So the data is stored on the bookies durably, and non-persistent topics and data is only in the memory of the brokers. You can have partitioned topics and non-partitioned topics. Partitioning is a way to scale more the brokers, but you really don't need partitioned topics in order to scale out the consumers. Even one single non-partitioned topic can have tens of consumers. You have tenants and namespaces. So topics are grouped in namespaces, and namespaces are part of tenants. And the tenants provide logical and physical isolation of resources. So you really can say to Pulsar to use only some machines for your tenant, or simply divide the resources at logical level and assign quotas and user things. And you have very fine-grained control over the configuration at any level, so you can configure things at system level, tenant level, namespace, and topic level. Pulsar was born in Yahoo. It's a big enterprise with many different internal clients and geo-replicated. So this is why Pulsar has this feature from the beginning. You have several subscription modes. You have the exclusive subscription mode, in which only one consumer can connect to a topic or to a partition to read the data. The failover subscription is the same as exclusive, but you can have multiple consumers connected to the single topic, but only one consumer at a time will receive data. And this is like Apache Kafka, if you know Kafka. And you have the shared mode. In the shared mode, this works very well also with non-partitioned topics, and you can connect many consumers, and Pulsar will dispatch messages to as many consumers as possible in order to achieve better throughput. And but without guarantees on ordering, because here we want to process the messages as fast as possible. And you have the key shared subscription, in which it is the same thing as the shared subscription, but Pulsar guarantees ordering in the processing per key. So you don't need partitions. It is just the message, the key of the message that drives the ordering. In Pulsar, the acknowledgement of messages is per message. So you acknowledge every single message to Pulsar. You have two subscription types. The durable subscription type, basically the status of the subscription, so the list of acknowledged messages is stored on BookKeeper. And the non-durable subscription type, in which the status is held only on the client side. You have two producer modes. This is very nice. In the regular normal producer mode, many producers can write to the same topic. In the exclusive mode, only one producer at a time can take the leadership of the topic or a partition. And so this is very useful if you want to use Pulsar as a write-ahead log for replicated state machine like a database, or you want to implement leader actions or other these kind of things. So we saw JMS and we saw Pulsar, how to map the two models. It's very easy and straightforward. I worked personally on the development of the the first client, JMS client for Pulsar, and it is very straightforward. A JMS topic is really like a Pulsar topic. A JMS queue can be emulated by a Pulsar topic just by enforcing that there can be only one shared durable subscription on the topic, because in one queue, for one queue, you can the constraint is that each message is dispatched only to one consumer at a time. And the JMS message is a Pulsar message with a payload and with an header properties. You have many consumer types in JMS, and you can map one-on-one these types with Pulsar subscription mode. One important thing to know is that in order to use JMS, you don't need additional components in your Pulsar cluster, no proxies that rewrite wide protocols. And in Pulsar, you have also Pulsar protocol handlers that are extensions to the Pulsar broker that allow Pulsar to speak other languages. So for instance, you can add an extension to speak the Kafka protocol in Pulsar or RabbitMQ protocol. But for JMS, this is not needed because JMS is not a wire protocol. It's only a Java API. So the Java client, the JMS Java client for Pulsar is simply a client library, nothing more. It's a bunch of classes, very, very easy. Let's see some code. Here we have a typical JMS client application with the standard Java, no Java Enterprise, no Jakarta Enterprise. Basically, you have to get a reference to the connection factory. And in this case, we are simply instantiating a Pulsar connection factory. You can get this connection factory from a JNDI registry, for instance, but you can build it simply by instantiating it. Usually, you provide the connection properties for your Pulsar cluster. The HTTP API is usually used for lookups for this service discovery, and the other binary protocol URL, it's for binary data. Pulsar is straightforward, and most of the time you just have to provide one of the two URLs. It depends on your cluster. But while you have once you have a connection factory, you write just regular JMS code. So you create a JMS context, you get a reference to destination. Here, create queue is not about creating a queue, but it is about creating a queue reference. And then you can write data to your destination and you can read data. It is very simple, the JMS API, and you can use it. If we go to a Java Enterprise, and we will see the example later, in the example, we have one producer application that is a singleton enterprise Java bean with a timer. So every 5 seconds, it will write a message. And the example here is interesting because in a Java Enterprise application, it is the container that provides the connection factory and the destination objects. This is for Apache TomEE, and here we are asking the container to inject the connection factory that I named Pulsar JavaX JMS connection factory and the queue, full queue. We will see this in TomEE, how to do it with TomEE. And then you use the JMS API. It is the container that deals with transactions. For the consumer, we are using a message-driven bean, and here you configure the message-driven bean with the destination, and the destination will be looked up in the JNDI registry. And the container will will consume messages and will call your on-message callback. And if no exception is thrown, the message will be automatically acknowledged. Still here the container will handle transactions. In the example that I'm going to show you later, we will see Apache TomEE. And in TomEE, in order to deploy the resource adapter, is very easy. You just have to put the RAR file somewhere, and you deploy the RAR, you pass the path, and you configure it. And also, you can create the queue. I'm naming this full queue, and this will be mapped to OpenEJB resource/full queue that we saw in the example here. And we configure the destination, and we are saying that a full queue is for full minus queue. And this is the physical destination on Pulsar. The demo uses Apache TomEE 8. It deploys the resource adapter with the JMS client. It is Starlight for JMS. I will give you the references in the last slide, and creates an initial object, the queue, like we saw here. And the two applications that I showed will be running. You can find the code on GitHub. Here it is. This is my GitHub, personal GitHub space. And basically, in the example, we're going to build the application with the two Java classes that we saw. It will download TomEE, and it will create two instances of TomEE, and copy the configuration files, deploy the RARs, configure some ports, deploy the two web applications, and start Pulsar standalone, start the two instances, and we will see in the logs. We are not going to use Pulsar standalone, that is a simple Docker image to run Pulsar locally. We're going to use free space on Astra. Astra is a cloud service for Cassandra and for Pulsar. And this is my free space. And I've created one topic. This is full queue. And so let's run the example. I'm not going to type all the commands. I created a simple script that does everything. So we are building the application. We are already starting the two TomEE instances, and then you will see the logs of the two applications. So we are on TomEE 2 that we are writing the messages, and TomEE 1, so it is a remote application on another place in the world that is receiving the messages. Not so big fun, but that's it. And yes, we produced 14 messages. That's it. It's very, very easy, and the application just simply uses the JMS API, like we saw. This is the message-driven bean. Very, 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 very easy. Okay, let's move forward. That's it. Let's wrap up what we saw. The JMS API is really like JDBC for databases, but this is for messaging systems. And in theory, you can easily switch between one JMS service to another service if you are using only the standard JMS API, and this is usually the case. Pulsar is a cloud-native messaging platform. It comes with multi-tenancy and geo-replication. It is horizontally scalable. Every component in the cluster can be scaled very easily, especially on Kubernetes. And Pulsar is open source. It is already has a big community, and so if you're using an open source software, you are not locked to any vendor. If you want to try Pulsar with JMS, you can just pick up the Starlight for JMS client. I worked on it. And you drop it on the class path and you use Pulsar connection factory. The same is for the resource adapter. My references, you can reach out to me on LinkedIn, on Twitter, or you can connect with the Pulsar community. This is the Pulsar repository. The website is pulsar.apache.org. This is the Pulsar JMS client, Starlight for JMS. And if you are curious, you can check out the JMS 2.0 specification on the official Jakarta website. So thank you. Let me take a look to the questions. The first question that I see here in chat, does the API or any of the implementation like RabbitMQ implement the concept of throttle, so only one queue element is returned at a time and the next element is not removed from the queue until the current one has been processed? Yes, if you are using an exclusive subscription, you have to process messages sequentially. You are not forced to acknowledge the message before receiving the message next to the one that you received. If you are using Pulsar, you can use the RabbitMQ API, and I can tell you that there is another open source project that is Starlight for RabbitMQ that implements the RabbitMQ API on top of Pulsar. So if you want the same semantics of RabbitMQ, yes, you can drop in the jar for the RabbitMQ protocol handler and it works out of the box. No, not so difficult. Next question. And does it support leases some messages, and what can one do with errors and timeouts? Okay, this is very interesting. So the consumer receives a message. There are mechanisms to detect that the consumer is dead, and the message is to be delivered to another consumer in the same group. So everything is configurable, and also the Pulsar consumer can negative acknowledge the message. So in case of processing error, the consumer can tell to Pulsar to dispatch the message again immediately or after some time. Does Pulsar support DLQ? Yes, it does. It is a feature that is present. Does Pulsar allow throttling? Yes, it does. The name in the Pulsar configuration is a dispatch rate or something like this. So you can throttle consumers and also producers. And there are also some mechanisms, for instance, to throttle producers if the consumers are not keeping up, are not processing data at enough speed, so that you can configure a maximum backlog on the processing of messages in terms of bytes and also number of messages, if I remember correctly. So you can say that if the consumers that are currently subscribed to a topic have a too big backlog, the producers must be throttled, and you can configure Pulsar to return an error to the producer or to simply throttle the writing, if I remember correctly. I hope that this is what you are looking for.
We do verbal questions now. I was just curious. Have anybody used this with just Spring Boot without using TomEE?
Oh, for Spring Boot, in the Starlight for JMS repository, there is an example how to use Spring Boot with JMS with Pulsar. And I am aware of some other adapters for Spring Boot. I can't remember the links, but yes, there is something in the community, not directly supported by the Pulsar community, but there are users that are provided this. And here in the repository of the JMS client, you can find a very straightforward, simple example of how to use Spring Boot.
Thank you.
Enrico, just out of curiosity, can you speak to companies that may be running this in the cloud, like AWS or GCP or something? Are they running it like on their own accounts, or are there companies that offer like services around it, maybe managed systems or managed services? Just curious if you know what the intersection of cloud and Pulsar is.
Pulsar comes natively with an Helm chart, so it is very simple to deploy it with on Kubernetes. It's very simple. There is an official Pulsar Helm chart that is maintained by the Pulsar community. At DataStax, we have another Helm chart, but basically with the same features. And there are also other Helm charts for Pulsar. So it is very easy to deploy Pulsar on the cloud. And there are also cloud providers like I showed up with Astra. We are providing support for Pulsar on the cloud in multiple regions. Yes. Is there an Helm script to deploy Pulsar? Yes. I can give you the link here.
Cool. Thanks, Enrico.
Probably in chat is better, but I'm used to use this, the Pulsar chart at DataStax, but there is also the official and chart for Pulsar. So I'm pasting this on Slack, on chat. Yes, probably currently the best way, the best way to deploy Pulsar is on Kubernetes. But in my previous company, I used it to run Pulsar using simply the jar files and packaging Pulsar using dependency management like with Maven. So because you can run it in many times, many flavors with Kubernetes, only the Docker images, or you can download the tarbos and run the processes, the program, the Pulsar program. It is written in Java, and it runs on JDK 8, but since the last year, the preferred JDK version is 11. All the Docker images, recent Docker images for Pulsar are with JDK 11.
I'm just learning about change feeds for Cosmos DB and probably other NoSQL databases. And I'm wondering if you have any knowledge about the relationship or the appropriateness of Pulsar for implementing a change feed on a
Sure.
non-relational database?
Sure. For instance, I personally worked and I'm working in the capture data change support for Cassandra and for Pulsar. And so currently you can run all of the Debezium connectors, CDC support from the Debezium on Pulsar.io. But there are also specific tools like, yes, I can share you the link to the Cassandra. This is, for instance, the CDC adapter for Cassandra and Pulsar. The enhanced. There is also a simpler CDC. No, there is no simpler. No, this is the only one. But yes, this is very common because it is more and more common that you connect your SQL or NoSQL database, and you get the changes. You push them to Pulsar or to a streaming platform, and then you process your data and you push them to another system. A very common case is to connect Cassandra with Elasticsearch. So you can connect with Cassandra, you can push your data to Pulsar, and still using Pulsar.io, you can push the data to Elasticsearch, so index your data.
Thank you.
All right. Well, we're kind of winding down here time-wise. Any other questions for Enrico from anybody? Okay, I'm guessing not. Enrico, thank you. That was a really interesting talk. I enjoyed learning about Pulsar there. If you want to go ahead and paste, actually, these references would be great if you want to paste them on the meetup page, or send them to me and I'll paste them on there.
Sure.
And then I'll have this recording available. Actually, let me stop the recording.
Oh, I got